collection of similar values. Oh, okay. Someone's, oops. Okay. So how do you make a list? So you define a list very similar to how you define any variable, except for you're going to put your list of values inside two of these square brackets. Okay. And they can hold any type of data in Python. They can hold integers, strings, floats, Booleans, any type. Okay. When you're doing it with integers, obviously, like you declare an integer, you don't need the little quotations around the tops. You can just keep it as just as is. When you're using strings, you need the quotations, obviously. One key component of strings or list is that they don't all need to be the same data type. So you can have a list that has a name, a number, or sorry, a string, number, a Boolean, doesn't matter the type, okay? But generally speaking, for most things that you guys will do, you guys will want to keep it the same type, okay? Especially for the stuff that we do in this class. So there's many ways to get values from list, but the most common way is to do it via indexing, okay? So if you have a list of 4 values or four variables, right? The first value in that list is index 0, okay? Anytime you're counting in programming, right? If you need to get index value, it always starts at 0, okay? So as you can see here, 101 would be the 0th index, or 303 is the second index, right? This is how you would retrieve a value. So if you wanted to print 303, right, you need to say the name of the list, right? And then 2 square brackets right next to it, and then the index numbers. So this will return 303, and that print statement will print out 303, okay? So using list, we can use them, like I said, we can use them to store any value, and then we can use those values like variables in things that we want to create, okay? So like, for example, here we have an ellipse, right? Instead of just putting the integers in there, normally we declare it like we did in the second week, where we talked about variables for the first time, and we put each value in there as is, okay? But if you plug in, say, like a list like this, right, for the ellipse, right, you're plugging in an entire list. The ellipse function in Python does not know what to do with that. It doesn't matter if you have 4 integers stored like it is here. When you put this in here, it's returning a list. You're putting a list where 4 integers should be, right? So the computer has a heart, doesn't understand, give you an error. Okay, so modifying list, very simple. Grab the index value, right? Same way that if you wanted to print that value, and then you set it equal to something else. So as you can see here, we have a list numbers. The first value is 2. We want to change it to 3. We just say numbers of 0, which is 2. We're not going to set it to 3. Very simple, very easy. It's just like using variables. So this will be our first question. So everyone get onto Top Hat when you're ready. Okay, so what will be the diameter of the ellipse drawn in setup? Okay, so this one here. So if we have x is this list of integers, right? We have x1 is equal to x1 plus 10, right? Then x3 is equal to x1 times 2, right? What will be the diameter shown here? Oh, I don't need this. And let me know when you guys have kind of all answered so I know when to move on. Have you two answered? You guys answered? Answered? Everyone answered? Not yet? Still waiting? Is everyone logged into Top Hat at least? Yeah, okay. here. How many answers do we have? We're missing one because we have someone in Zoom as well. No? All right, so it looks like most of you guys have answered. So if you put the answer 100, you got it right. And I'll walk you guys through it quickly. So remember what I talked about, updating variables and then resetting them, right? So in this first bit here, obviously x1 is what? It's 40. We take 40 here, we add it to 10, and then we reset that value. So this value becomes actually 50. It's not 40 anymore. And then the last value, x3, will be that value that we just created times 2. So 50 times 2 is 100. Diameter is these values here. There you go. It gives you a diameter of 100. Yeah. So we can make our list bigger. That's one of the key functions of a list, is the length is mutable. You can change it. If you want to add a value, sorry, well, this is just creating a list, but we want to make them bigger. So if you want to add a value to the end of a list, right, you need to use the name of the list dot append two brackets, and then inside those brackets is the value you're adding. And this value gets appended to the end of the list. So because originally we had eggs, ham, and cheese, onions, that was our original list. We added milk. Milk becomes the last value on that list. Then we add bread again, and then bread becomes the last value on that list. Okay. So appending, when you use that append function, it always happens at the end. And then removing items is very similar, except for you can remove by value. So it doesn't matter where it is, as long as you put in the correct name, it will remove it from the list at any point. Okay. Am I talking on Zoom? I am. Okay. We can also get the length of our list. It's a very key feature, especially when we start using list with loops. Okay. Many times there'll be times where you need to iterate through every value of a list. And you guys will see with loops, there's many ways to do that, but getting the length of a list is very, very handy. So very simply, we use this length function, okay? And if we put that length, if we put something in between those two brackets of length, it will return how many values are starting there. You can use this with strings as well. You can return the length of a string as well if you want to put in there. But for a list, what it's going to count is it's going to count the number of values you have, okay? And this will print out 4, okay? Do you guys notice how the length of the list is the last index value of a list is 1 minus the length of the list? It's because we start counting at 0, remember? So this is the 0th value, 0, 1, 2, 3, but the length is 4. It's just one little thing to keep in mind. These are some common methods or functions that you can use with list. So we went over remove and append. We went over length. Index returns the index value of a value at a string or in a list. So if you wanted to, let's go back to our eggs, this one here. If you wanted to find the index value of, say, milk, you would go shopping list.index milk, and it will return 4. Okay. There's also sort, which will sort the items of the list in place from lowest value to highest value. This depends a little bit, I believe, on ASCII values, which you guys might will learn about later. It's not really too important right now. And then reverse will just flip the elements of the list. So the last index will become the first index. Okay. So let's get started with exercise 1. So we want you guys to use a list to draw 4 rectangles that grow with your mouse X. That kind of follow it. Okay. So a quick hint, the list should store the values that are different for each bar. Okay. Keep that in mind. There's also more things to remember. So you also remember like which arguments are initializing the rectangles, and which ones should be included in your list. Remember, we said the ones that are included in the list should be the ones that are different for every rectangle. Okay. X is the same for all the bars, right? And the width, or I guess the length in this case of the bars, is determined by the mouse coordinate, right? And height is the same for all the bars, right? They're the same thickness. So how can you guys, which values can you put into the list that would consist of different values for each bar? Okay, we'll give you guys a couple of minutes to get started with that, and let us know if you need any help. It's a bit of an odd way to use a list, if I'm being honest, but let's go over the solutions real quick so you guys get an idea. So we asked you guys in the beginning to store the values that were different between each rectangle within a list, right? So if you did that properly, what it would have looked like is your list, right, would have stored the y coordinates of each rectangle, okay? Then of course you call your setup, right? You need to declare y list global, which I saw everyone do, so it was good to see, right? And then you have your background, you have your fill, and then so on and so on. I added this in here, I just wanted to see, but if we run this, it should work. Also, you can see at the bottom the mouse X, my mouse X. You see at the very bottom underneath the last bar. Just to give you an idea, that's how fast this program is running. Okay, so this is also an example of a loop, which is what we're going to cover next. Okay, so def draw, because of the way this Python library works, def draw is called like a loop. It just keeps running until you stop it. Okay, so this is what we're going to cover next, how loops work. Okay, and I don't know why this is there. We'll just do this. Okay, so most of you got that, so let's move on. So loops, again, bread and butter of Python. You need to know this if you want to code any further in Python. Okay, so what are loops? Loops are essentially a piece of code that repeat a certain section of code. I know it sounds weird to say, but that's essentially what it is. Oops, I wasn't showing my camera on Zoom. So, right, so we have an analogy for loops, right? You can kind of think of it as going to the dentist. So the dentist starts whenever they're cleaning your teeth. They'll start out one tooth, and then once they're done cleaning it, they'll move to the next tooth, right? It's kind of like a loop, right? At least the loop that we're going to study today. There's different types where we're going to look at one specific one today. But they check one tooth. Once that tooth is done, then they move on to the next tooth. Like in code, you could execute a set of code for a certain instance, and then once that piece of code is done, you move on to the next instance. Okay, so you can combine loops with list, and this is what I was talking about, right? Is this loop, this for loop that we have here, this is one type of loop. There's other types. Another popular one is while loops, but we're going to focus on the for loop today. So the for loop, right, in this case is iterating through each piece of, or each element of the list, right? So the way you declare a loop, right, is you write for, and then item in shopping list. So pay attention here because this is kind of the key. So you need to declare a specific variable. A lot of times when you're in Python code and say you're dealing with numbers, a lot of people use X or I. Those are common ones to use within loops. You can name it whatever you want, but this is just say for a element in this list. Okay, what this means is that the first item that is set here will be set to the first value of the list. What will happen then is that any code that is printed underneath this list and indented will be run for this instance of that list. So in this case, the only piece of code we have is print item. So this loop will continue through each and every value of the list until all the items are printed. Okay. Also, really quick note, this is very similar to like def draw. Like I mentioned, like def draw runs infinitely. This is very similar, except for def draw has nothing that will end it unless you guys put something in there or stop the code manually. Make sure when you're declaring your for loops that you keep the little semicolons at the end here and you keep it indented, one tab, like you guys do with the def draw and def setup functions. Same sort of deal. Okay. We can let's just continue on. So quick question, right? It's another top hat question worth points. Remember, those points get you a prize at the end, so it's important you guys answer those. If we have this piece of code here, we have numbers is equal to this list, and x is equal to 0 for numbers for a number in numbers. What will be the final print after? Okay, the print statement. Now, keep in mind, just real quick, look where this print statement is relative to the loop. You guys see how it's not indented like this x plus equals number? So it's not going to run every time. It's just going to run once. I'll give you guys that little hint, okay? So open that up on Top Hat and click away. Sorry? Oh, it might be just starting. Just give it a quick sec. Is it there now? Perfect. Do-do-do. Yeah, just one loop. So one quick thing I'll mention quickly here. Wow, I said quickly a lot in that sentence. The loop ends, right, once there are no more values left in the list. That's the way this loop is set up. Okay. Python can recognize that this list has an end, and it will iterate through each and every value without missing one. Okay. Who? Yes. It'll still go through. There's nothing like the only thing stopping this loop right now is the number of values inside the loop, inside the list. So there's nothing saying that, oh, we want to stop this loop when we hit a certain value. No, it's going to go through each and every value. The print will just automatically run. So, but it does matter in this case, just based on output. So in this case, you're only going to have one value printed at the end. That's the final value of X. If you put that print statement inside of X, you would get the value of X each time the loop runs. Yeah. So a lot of times in like when you're building code in like assignments and stuff and you have loops, print statements are really handy to see what values are coming through. Because if you have certain, because a lot of times you will mix if and else statements inside loops, right? And you need to see if the correct values are being used or being whatnot. So print statements are very handy that way. But in this case, just one value will be printed because it's not indented, right? Python reads that indentation and says, okay, this is outside of the loop. I'm not going to read it. No. We have all? Okay, perfect. All right. So if you said the answer was 10, you got it right. Okay, so I'll just run you guys through it real quickly. So again, we have 3 values. So for each and every number in numbers, we're going to add it to X. Well, for the first value of 2, X is 0. So we're going to add 2 to 0. You get 2. Add 3 to 2, you get 5. Add 5 to 5, you get 10. Okay. Final print statement at the end, right? Like I was saying earlier to one of our students here, if this print statement was inside the loop, you would see the value of X being printed out every time the loop runs. But since it's not inside the loop, it's outside the loop because there's no indentation here. The loop just runs on. Yeah. So like this loop, right? So this is declaring a loop. We have a for loop here, okay? Anything indented after this line will be run for each instance of this loop, right? So if I wanted to put this print statement in here, right? What would happen is for our first value, it would be for number in numbers, right? So the first number 2 goes in, you add 2 to the value of X, which is 0 at that point, and then you would print the value of X, which would be 2. And then you would do the same for 3, except for 3 would go through, 3 would get added to 2, you would get 5, and then it would print out 5, right? In this case, since you can see that print statement, you see how the print, it doesn't have an indentation like the X does here, right? That means it's outside of the loop. So it won't get read until this loop completes, or in this case, until every value has been put through this loop. Does that make sense? Okay. So why use loops, right? And let's look at exercise 1 again, okay? So the they're good for repetition. So if you repeat something a number of times, it's good to put it through a loop. Makes it very, very efficient. And we can, like I said, we can replace repeating code, right? So in your guys' previous assignment or previous exercise, the first one we did today, you guys all had a rectangle like this, y list of 0, y, and so on, right? Wouldn't there be a nice way if you could just write this? That took you 4 lines to write. Here you can write it in 3, right? And when your programs get more dense and the bigger they get, that saves you a lot of computing time. Okay. So you can always change repetition and loops. So like we said, oh, hello. So like, for y list, right? You can now plug in y into your loops. G colon. Each time it iterates through, you guys can see that the values of y is changing, right? So let's try this again. So for this exercise, I want you guys to use the list and a for loop to create some balls falling from the ceiling. Okay. So think about how the loop helps us draw the circles, right? And yeah. Also keep an eye out to the center position of the X, like the X is different, right? Think about a way to store multiple X positions, and yeah, repeat the process as many times. But again, you're repeating a process, so use a loop. It's much more efficient, easier to read as well. Like the balls are speeding up as they go down. So like I had that problem too when I first did this. I didn't think that the balls were speeding up. They are indeed speeding up. They are accelerating downwards. Like guys, who's ever there on Zoom, I just said if you've gotten it to work, I want you guys to see if you guys can try and get it so that it loops like it does in the picture. You can do that. think of using if statements, think of which conditions you want to use to reset it and what values you want to reset. Okay, give that a shot. All right, so let's move on. Okay, so again, these are the following circles. I'll show you guys a quick demonstration. I actually challenged myself to get it to loop, but so depending on how you did this, right? Like we said, keep the X positions in a list, right? Those are the values that are different between each. It's a good way to keep track. So that's what we did here. Then we initialized our Y position and our Y speed, right? We ended up making these circles in this case. Oh my goodness, give me a minute. My brain is farting. About 15 or about 30 pixels in diameter. So 10's a good base for the Y. That's fine. Declare those all global, background, fill, right? And then we declare our, we have to increase our speed, right? So like we said, the balls are accelerating downwards. So we're going to increase our Y position by our speed. So that's going to move them down. But then we're also going to increment our speed. So that makes them accelerated. So the distance between where the ball was and the ball will be in the next loop through is going to increase, which will make it seem like the ball is going down faster because of how fast this program runs. Okay. And then for every value that you have in this X position list, right, is basically the X position of every circle that you're creating. That's what's going through here. So it's going through every value and creating a circle, okay, with the values that you altered beforehand. Okay. Just ignore this bottom part here. So as you can see, the ball is accelerating. This bottom part is something that I did here, and this is what's causing the balls to loop, right? So if we were to comment this out, can I do it like this? I can. Let's go. So if I were to comment that out, the balls just stop. Actually, they keep falling. You just can't see it because they're outside of the window. Okay. But if I take this out, can anyone describe to me what this for if loop is doing here? What condition is it checking for? And then what is it doing? Anyone raise a hand? Anyone chat maybe answer? If you guys know. Any hands? Any hands raised? Yes. Right. Break it down for me. How is it knowing when to reset? Right. What is the if step mean checking?
When the Y value gets to
Right. Resets the Y position and resets the speed. Right. There you go. Okay. So that's a good example of how to use an if statement. Okay. Right. Here we're checking to see if, right, a certain value is hit. Right. In this case, we want to see if the Y position is greater than or equal to 300. Why do you guys think I said greater than or equal to and not just equal to 300? Anyone venture a guess? It's because that the program's running so fast, and like for me, they start at a position of 10 and they increment by 0.5. Yes, at some point they probably hit 300. This is just a sure way to make sure that the balls will hit a certain point that they should not go and they will return. Okay. There are little tips and tricks that you guys can use in your code to make sure of things, you know? So like example, I want to make sure that these balls stop at a certain point, right? I'm not going to let the computer, like I'm giving the computer a much larger window to recognize that it should stop, essentially. That's the way I can put it. Okay. All right, let's move on. We're almost done. So you can mix loops and if statements, like I showed you guys, right? The def draw is an example of a loop. It runs continuously, right? It's not technically a loop. It is a function that runs over and over, but it is a way to think of a loop, right? And inside that loop, we had an if statement, right? This could also be used if you wanted to remove a, if you guys remember the list that we did with the grocery items where it was like eggs, ham, cheese, or whatever. If you wanted to go through that list and remove cheese, well, for item in shopping list, right, that we had before, right? If X is equal to cheese, then you can remove the cheese on that condition, and then you'll get a list without cheese. I don't know who likes that, but it's not me. I love cheese. Oh, we have something in chat. Nice, Sean. So you can mix, this is an example of mixing for loops and if statements, right? If my thing would click. So for X in each position of X position, it's a bit of a complicated, but X is, as you guys can see here by this arrow, X starts off to be 40, right? If X is greater than 150, right? We're going to set the color to this ellipse that gets defined at the end to red. If it's not, then it's going to be set to this color, okay? So since X is less than 150, we're going to get a yellow circle, and then it's going to loop through, right? Everything has been written. Now X is, now for when X is 80, we're going to go through. That if statement's not going to run because X is not indeed less than or greater than 150. Then we're going to go to the else, and then we're going to run the eclipse. Keep going. Oh, look, we hit 160. Hey, that if statement's going to run. That else statement is not going to run. There you go. Okay. So that pretty much sums it up for today. Mixing list loops and if statements is very important. It's something you guys do a lot of. These are the exercises for this week. Okay, so you have your bug busters. This would be your exercise for this week. Similar concepts to what you guys are doing before, but please try and use things that you have learned today in these exercises, because they will help your understanding of them greatly. Okay, and then for Pythonic Lava, this is what you guys have. Okay, this one, especially the loading one, is going to need a very nice little if statement, if else statement. Okay, and that's pretty much it. If you guys finish those, then try these ones. Okay, this one's really cool and really satisfying once you get it working. I tried it, and it took me a good 30 minutes. I know that's just because I have a background in this stuff, so it's a little bit easier for me. But if you guys get it in less than 30 minutes, I'll be impressed. And then try this one as well. See if you can make Pong. And remember this old game, first video game ever made, if I'm correct. Yeah, that's pretty much it for today, guys. So yeah, if you have any questions, we'll be here. And yeah, if you guys want to stick around and try some more things, you guys got about 10 minutes, so feel free. That's it for today. Thanks, guys. Anyone on Zoom have any questions? Sorry, guys, I'm trying not to neglect you. I promise. It's just 2 different platforms. No questions, Justine? Good to hear. Nope, good. All right, you guys are free to go if you'd like. If you want to stick around and ask any more questions, if one comes to you, feel free. We will be here. Nice to see you guys interact. Yeah, you're welcome, Sean. Nice to see you guys interacting on Zoom. Nice to see you. Do.